So I will talk about biochar in an enhanced weathering session. Woo! Is there anybody who does not know what biochar is? Okay, you take biomass, you heat it up to several hundred degrees of Celsius in an oxygen-limited environment, and then the then the biomass is not burning to CO2, but it converts into char. So it's very similar to the coal we burn in coal plants. And you can put it in soil, and then you store the carbon in the soil for a very long time. You make it more fertile, you make it more drought resistant, and so on. That's biochar. So I present you my project ROCKCHAR. This is funded by the Klaus Tschira Booster Fund. So this is a high risk, high gain, and high fun project. And I have several cooperation partners from the industry, which I will tell you more about later. So let's look where can we store carbon in the Earth system. There are several possibilities. These are not all by far, but when you look at this from a geoscientist perspective, you are missing like how all of these methods are interacting with each other. And everything is very isolated. And what I also want to criticize on this is, on land, we have a very limited space to do carbon dioxide removal. So area is always in competition with crop growing and settlement and infrastructure and so on. So let's imagine what we can do with 1 hectare on land in CDR. So first of all, this hectare is consisting of soil, groundwater, and the air above it. And we can do different things like growing trees, re-wet peatland, growing energy crops, and most important, I think, is growing crops to feed humanity. But let's assume that we have the space to do some bags. Then we can draw down or we can store a certain amount of carbon dioxide per hectare per year. We don't change the area, but if we also deposit biochar in the soil, we can draw down even more carbon dioxide at the same area without changing anything. We can add enhanced weathering, and we increase the CDR more and more. And there was recently a paper published by Onwald who described that the amount of biomass was increasing when basalt and biochar was co-deployed in the soil. So there's a potential of synergy effects. And I like to refer you also to poster number 15, 18, and 19, which are dealing with this question. Further, these biochar and enhanced weathering have an impact on soil organic carbon. They increase it, they can stabilize it, so we have more carbon dioxide removal. And we have a long-term remote effect on the ocean through alkalinization. And at the end, we have much more CO2 drawdown on the same area. So we have to think of combining different methods, something that I called multidimensional CDR, because we're not just using the 3D space, we have another dimension like the time when CDR is delivered, the permanence of CDR, the ecosystem service, and so on. So there's much, much more to think about and much, much more that we can use. And when we do this, we are doing something that we call soil engineering. Recently, soil engineering has been proposed in several publications from Janssens and Svoboda, like engineering soils or remineralizing soils. And my colleagues, Thorben and Jens, they have made a huge scheme of what are the potential benefits if we add or if we co-deploy biochar and enhanced weathering. So there are many, many possible benefits, like we have a bigger nutrient pool, we could have, we are stabilizing the soil pH, we have a enhanced soil biota, and so on. And if we have clay formation from enhanced weathering, we have dissolved organic carbon that can attach to the clay. We have the formation of aggregation and mineral-associated organic matter, which you can see here, which is also protecting organic biomass. And calcium coating and priming, these are two things that affect biochar, so the stability of biochar, which is triggered by the amount of minerals in the soil, and so on. So lots of things are going on. And another point that we as natural scientists also oversee very often is the socio-economic benefits. A very good example for this is, again, biochar, because we are growing crops on the field, we have waste biomass, we turn this into biochar and we put it back on the field. We store carbon and we make the soils more fertile. We also gain electricity when we do the pyrolysis in these modern plants here. So we produce excess energy for the grid or for batteries. And so this is, we're using the circular economy and we put a value into CO2. We're not dumping it as a waste product deep underground. We are creating a resource and we can sell this resource to increase or improve soil quality. Many biochar projects in the global south also have a significant regional development, and they are also well accepted from the people because it gives them a better life, a more higher food security, and so on. And by all this together, we can create pull factors instead of push factors. So pull factors are, the other way around. Instead of telling a farmer, you have to do this, the farmers come to you and say, please let me participate because I heard it's a fantastic method to sustain my agriculture growth. What comes next? Oh, okay, now I'm talking about ROCKCHAR. So ROCKCHAR is not the simple co-deployment of enhanced weathering and biochar. It's the heat of passion between biological and geochemical CDR. So this is also known as PyMiCCS, which is the name of another project, which is also dealing with the same stuff. So PyMiCCS stands for Pyrogenic Carbon, Mineral Weathering, and CCS. And what I do is I mix rock powder with biomass, and then I co-pyrolyze both together at 650 degrees for 15 minutes, and what comes out is ROCKCHAR. To make sure that minerals and biomass can interact with each other during pyrolysis, I have to pelletize them. And this is also very convenient because when I spread it on the field, I have less dust production. Normally, especially when you deploy rock powder, you have this huge clouds of dust, which doesn't make you a famous person around that area. And so what I used for ROCKCHAR is I took spruce chips and soybean meal. Soybean meal was a compromise because I needed a biomass which contains a little bit of oil to make these pellets. And then I had different variants, like adding bazanite, adding dunite, which was supplied by Sibelco, adding crushed returned concrete from silicate, so they are sitting in Ireland. I am adding steel slag from ThyssenKrupp, and that's the same steel slag that Reinaldy is also using in his experiment. And all was pyrolyzed by the company Novocarbo. It's a biochar company. So why should we put so much work into co-pyrolyzing those two? Because it's really extra work. Well, there is a very excellent review paper from Buss et al. From 2022 that collected together all the information we have on co-pyrolysis. So first of all, we have a higher output. Normally, if you put a ton of biomass into the pyrolysis, you get out 200 kilograms of biochar because you lose about 80% of the weight. Most of it is water, and the rest is outgassing carbon in forms of methane, for example. And when you add minerals, these minerals do not disappear at 650 degrees, so you get more mass coming out of your pyrolysis. And to give you an example, I have something here. I have one biochar, a normal biochar, and one ROCKCHAR with minerals added, and you can feel that they have a different weight. And we also get a higher yield in carbon and a higher yield in stable carbon. So biochar often contains stable and labile carbon, and the higher the amount of stable carbon, the more carbon will remain in the soil. Very easy. Often, the feedstock of minerals is much cheaper than the biomass, so you can have lower costs, and again, you have the circular economy. And the reason why you have more carbon in your biochar has two reasons. You have a physical and a chemical reaction. So the physical reaction, and therefore I pelletize it, is just happening that the minerals have a protective layer around the biomass and protect it from outgassing through, during the pyrolysis. And the second one, this is very important, if we have ions that are available, they can make new bondings with carbon, like metallic or non-metallic bonds, and then we have more carbon, magnesium-carbon bonds, for example, and this leads to a smaller outgassing of carbon as well. And I also have another one, sorry. So here I have pure biomass, and biomass combined with rock powder, and you can also feel again that it has another weight. Please put it, return it afterwards and don't eat it, and please, yeah. Okay. So I recently started my experiments in a CO2 incubator. So I have several soil columns filled with the soil and different amendments of the ROCKCHAR. I rinse them regularly, and the water that is leaching out, there I'm doing a lot of different measurements on it, and I can tell you two things that I have recently observed. I'm still in the middle of everything, but two things I can present. So the first rocking observation is we have a suppressed DOC leaching, and this is also referring to poster number 18. So one problem is when we put biochar or enhanced weathering in soils, we increase the pH of the soil, and we can observe that more dissolved organic carbon is leaching out of the soil. The higher pH is triggering microorganisms to be more active in consuming more organic matter. So we are losing some organic carbon at the beginning, which you can clearly see here. We have a very high pH on the green and the yellow curve, and also a very high leaching of DOC. So what I have now observed is the ROCKCHAR that I did with my steel slag, and steel slag is causing a very high pH shift. The ROCKCHAR with steel slag is not changing the pH of my soil so much. So it's compared to the other one, so the pure steel slag and the steel slag with biochar, the co-deployment, it's quite low. And we can, and I can see the immediate effect on the DOC leaching that less organic carbon is lost from the soil. So obviously, the CDR performance or the CDR potential of my ROCKCHAR based on steel slag is better than I just put than the simple co-deployment or the single deployment of steel slag. Okay, all photos? Yeah. Okay, and then the second rocking observations I made is I have an increased magnesium release. Again, I'm comparing ROCKCHARs against biochar mineral deployment and the mineral deployment. This time it's dunite. So the blue graphs you can see, this is ROCKCHAR based on dunite, and they release much more magnesium compared to pure dunite. And so when dunite weathers, you expect a certain ratio of magnesium silica, and you can see that if you look at magnesium and silica, the blue curves are, or the ROCKCHAR based on dunite is releasing very small amounts of silica, so it should release much more because it's also reaching a lot of magnesium. I hope that's clear. So something is weird here, and I had a chat about it with Ingrid, who will also talk in a few moments, and she mentioned serpentine. So the dunite I used contains 11% serpentine. And if you heat serpentine to 600 or 700 degrees, you thermally activate it and it becomes more reactive. And my ROCKCHAR was at 650 degrees, so I have obviously activated it, and now the dunite in my ROCKCHAR is more reactive than the simple dunite, which was not heated. This is a possible interpretation of this. This is not the end of the story, but this is what I can see so far. Coming to an end. So take home for you is the co-pyrolysis changes the properties and likely the CDR potential of these kinds of biochars. And the outlook is, I will proceed with my experiments until mid-25, publish it afterwards. I have another proposal pending called superchar, where I take human shit and chicken shit and make biochar out of it. It's a fantastic project, I will tell you in 2 years. And I will drop out of academia somehow to turn science to action. And if you like the idea, if you're hooked on ROCKCHAR, call me, drop me a message, or use the session link. We have a QR code where you can find all relevant links from all speakers. And the EduRoam Wi-Fi is blocking this page. So if you scan it, just bookmark it, and when you're in another Wi-Fi, then you can see all the links. So we have all our contact details and interesting other links. And this, I'm coming to an end. And as you have been very brave with me, I have an attendance certificate for you today. This one here. So yeah, you can give it a round, and thank you very much.